In this video, we are going to be focusing on set. Let's assume you are given this kind of problem that says you should consider a universal set. Universal set is given to be 1, 2, 3, 4 up to 9. And you are given another set which is set A, 1, 2, 5 and 6. You are given set B, 2, 5 and 7, set C, 1, 3, 5, 7 and 9. And you are asked to find A intersection of B and A intersection of C. How can we solve this problem? When we set A intersection of B, this is simply the intersection of A and B, which include elements to both A and B. In this case, let's say we are given A. What is our A? Our element of A is 1, 2, 5 and 6. An element of B is simply 2, 5 and 7. And here we are asked to find A intersection of B, which is unknown. A intersection of B is simply going to be 2 and 5. Because in this case, we have 1 here, we doesn't have 1. But we have 2 and 5 in A, we also have 2 and 5 in B. Therefore, 2 and 5 is simply the intersection. Therefore, we can say A intersection of B is simply going to be 2 and 5. You can also represent this problem using the diagram, which we can set, let's say this is set A and this is set B. In the case of set B, the intersection is what, 2 and 5 at the middle, and this is set A. When you remove 2 and 5 from set A, you are going to be left with what, 1 and 6. In set B, when you remove 2 and 5, you are just going to be left with what, 7. So this is it. Remember, here we have 7 before the bracket. What if I are asked to find A intersection of C? A intersection of C. How can we solve this problem? Let's bring our data back. Our set A is simply 1, 2, 5 and 6. And our set C is simply 1, 3, 5, 7 and 9. The A intersection of C is simply going to be the same thing as A intersection of B. The same way we find this is how we're going to find this. A intersection of C is also simply the intersection of set A and C, which includes elements to both. Therefore, we have 1 here, A intersection of B. Since we have 1 in both, it's simply going to be 1. We have 2, here is 3. We can't insert that. But we have 5 and here we have 5. Therefore, it's going to be 1, 5, 1 and 5, and that is all. In this case, we can also represent it using the diagram. We can say, if this is set A and this is set C. Let's arrange our element. The common element is what? 1 and 5. If we remove 1 and 5 from C, you are going to be left with 3, 7 and 9. What if you remove 1 and 5 from set A? You are going to be left with 2 and 6. So, this is it for this problem. The next problem, we are asked to find A complement and C complement. When we set A complement, what does that mean? This is simply means it contains all elements in the universal set but not in set A. In this problem, our universal set is given to be 1 to 9, 4, 5, 6, 7, 8 up to 9. And we have to find A complement. In this case, let's write down our A. Remember, our A is what? 1, 2, 5 and 6. How can we find our A complement? We can just do it this way by getting rid of the common terms here. 1, 1, 2, 2, Here we have 3, here we doesn't have 3, but here we have 5, here we have 5, here we have 6, here we have 6. A complement is going to be 1, 4, sorry, 3, 4, 3, 4, 7, 8, and 9. We're going to use the same technique or the same method to find C complement. In this case, C complement also means it contains all elements in the universal set but not in set C. The same thing, our universal set is simply going to be 1, 2 up to 9. Our C is what? Set of C is 1, 3, 5, 7, and 9. In this case, let's get rid out of the common terms here, or the common element. 1 will go with 1, 3 will go with 3, 5 will go with 5, 7 will go with 7, 9 will go with 9. So therefore, C complement are going to be left with 2, 4, 6, 8. Let's try the next problem, which is C. In this case, we are asked to find A symmetric of B and A symmetric of C. How can we solve this problem? Here we are asked to find a symmetric difference of B and a symmetric difference of C. How can we solve this problem? When we say symmetric of A and B, this simply means it contains elements that are either in set A or B but not in both. Let's say we are given set A. We know our set A is here, which is what? 1, 2, 5, and 6. And we are given set B. Set B in this problem is 2, 5, and 7. And we are asked to find A with the symmetric difference of B. Let's start with the first one. How can we find this problem? Remember, we said when we say symmetric of A and B, it simply means it contains elements that are in either A or B but not in both. So 1 is just in A but not in B. 1 is included. We have 3. Alright. We have 3 because no, we doesn't have 3 here, but we have do we have 4? No, we doesn't have 4. Do we have 5? Yeah, we have 5 in both. Next we have 6 and we have 7. What about asymmetric of C? Here we said A with the symmetric difference of C, and we said our A is what? 1, 2. Am I right? 1, 2, 5, 6. And we are given C. C is 1, 3, 5, 7, 9. The A with symmetric difference of C is simply going to be 2, 3, 6, 7, and 9. Let's try the D, the problem in D. In this case, we are given set difference. We are given A with the difference of B and A with the difference of C, and we are asked to find both. Let's say you are asked to find A with the difference of B. In this case, the set difference of A and B contains elements that are in A, that are in set A but not in set B. That is what it simply means in simple terms. Let's say our A here is what? 1, 2, 5, and 6. And B here is what? Set B is 2, 5, and 7. And you have to find the difference of 2. I will repeat. We said the set difference of A and B contains elements that are in A but not in B. Which element here do we have in A but we doesn't have it in B? I think in this case we are simply going to be left with 1 and 6, because 1 and 6 are the only element which we have in set which we have in A but we doesn't have in B. Therefore, A with difference of B is simply going to be 1 and 6. The next one is what? A with the difference of B. Am I right? No. A with difference of C, because we are done with that one. Here we have to find A with difference of C. Let's still bring our data back. If A is simply going to be 1, 2, 5, and 6. I'm just copying this from here. And our C is what? Our C is going to be 1, 3, 5, and 7. How can we solve this problem? Our A with the difference of C is simply going to be, which element do we have in A but we doesn't have it in B? This element, we have 1 in common, we doesn't have 2, but we have 2 up there. Next is what? 6. Let's try another problem. The last one said we should find A union C with difference of what? B. The difference of B. Alright, how can we solve this problem? And the next one, it says we should find let's just stop here for now. A union C with difference of B. Let's copy it here and solve it. A union C with difference of B. In this problem, our A here is what? 1, 2, 5, and 6. Those are the elements. Our our C here is simply going to be 1, 3, 5, and 7. What is our A union C? The union of A and C is simply going to be 1, 2, 3. We doesn't have 4, but we have 5. We also have 6, and we also have 7. In this case, next thing we need to do is to find what? We have already found our A union C. Next is to find the difference with B. Therefore, our A union C, which is 1, 2, up to 7, 3 without 4, 5, 6, 7. And our B here is going to be what? Our B here is 2, 5, and 7. Notice that we have 2 in common, we have 5 in common, we have 7 in common. Therefore, the difference of A union C with respect to B is simply going to be 1, 3, and 6. So this is it for this problem. Feel free to try the last one. Thank you for watching. In this video,